Hello, everyone. Welcome to your first video notes of second semester. If you had me first semester, you're used to this. If you didn't, make sure you pick up on it as quick as you can. First thing is your sound on. If it's not, or your sound doesn't work, fix it quickly. Okay. Second thing, make sure that you're paying attention. Don't just get through this to mark it off a list. Try to learn from it. Okay. I'm not expecting you to learn everything that I teach you here just by watching the video, but you should at least try. Okay. So today we're jumping into scientific notation, which is something that you should be used to. You've done it before. You'll see this on all my notes. The first thing you're going to see is the learning targets. So there's 3 of them today. I can write a number in scientific notation. I can order numbers from least to greatest or greatest to least that are written in scientific notation, or I can multiply numbers that are in scientific notation. So what is scientific notation and why do we use it? So scientific notation is a way of writing numbers that are either very large or very small. All right. We have a generic form of a times 10 to the n, where a and n are just numbers, but a specifically has to be between 1 and 10. Now, 1, it could be equal to 1. That's what the inequality says. Could be equal to 1. It cannot be equal to 10. All right, so the first example here, which of the following numbers is written in scientific notation? I want you to answer the play posit question that's going to pop up on your screen now. Okay, the answer is B, but let's go through and talk about why the other ones are wrong. A, 52 is bigger than 10. So that's not a good spot for A, not a good number for A. Okay, same thing with C, except that's less than 1. That's bad. We don't want that. Okay, that's why A and C are out. D, what's wrong with D? It's the plus. Scientific notation always has multiplication, okay? Which is why B is your correct answer. Notice that N can actually be a negative exponent. That's fine. N can be negative. That's totally fine. All right. I'm going to scroll down here and look at our first learning target, writing a number in scientific notation. So this is a big number, right? 5,700,000,000. Okay, we're going to write that in scientific notation. We'll come back to that blank here in a second. The thought process. Again, this is a thought process. This is not necessarily writing stuff down. This is just what should be going through your head. Is this a big number or a small number? Well, it's pretty obvious this is a big number, but for future reference, it's a number. A big number is a number bigger than 10. Okay. A small number would be a number less than 1. Wondering where I get those numbers? Look back at what A has to be. Anything bigger than 10, considered a big number. Anything less than 1, considered a small number. Where is the decimal currently located? Right now, it's at the end of the number. So at the end of the last 0, okay? So it's right there. Where should it be located? Between the 5 and the 7. Okay, so it needs to be right in there. Okay, how many places does the decimal need to move? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. It needs to move 9 spots. That number 9 is your exponent. Now, I just referenced it above, that the number could be negative, okay? Which leads to the last bullet point here. Is this a big or small number? I've already asked that. It's big, but it's going to lead to these last 2 things here. A big number means a positive exponent, and a small number means a negative exponent. All right. So this is a big number, so it's a positive exponent, so it's a positive 9. Okay. A small number means a negative exponent. I want to make sure I point this out right now. A negative exponent does not make the number negative. The number is not negative. It's just small. The exponent's negative, but that doesn't mean the number itself is negative. Okay, so let's answer this question. We need to move the decimal 9 spots, and it needs to be between the 5 and the 7. So the decimal is now between 5 and 7. So 5.7 times 10 to the positive 9th. Okay. Another question here, right? 0.000031 in scientific notation. All right. So right now the decimal is visible. It's right there. It needs to be between the 3 and the 1. So 3.1 is where it needs to be. I'm just going to go ahead and write that. Now I need to move that decimal. However many times I move it is my exponent. So 1, 2, 3, 4, 5, 6, 7. I moved it 7 spots. This is a small number though. A small number has a negative exponent. So -7. Okay. What about writing a number in standard notation? Okay, so you'll hear me say standard notation. You might also hear me say decimal form. They mean the same thing. Basically, it's just going the other way. So I'm giving you a number in scientific notation, and you want to write it out. So 5.21 times 10 to the 4th. I'm going to come back to that, just like I did in the last one. Your thought process here should be the exponent is a positive number. So this is a big number. So if it's a positive exponent, it's a big number, and I move the decimal to the right. I move the decimal to the right, it's going to make the number bigger. Well, it's not really getting bigger, but as you move it 4 spots. So 5, 2, 1, that's 2 spots. 2 more spots, that's 2 more zeros. 52,100 is what that number is. If the exponent were negative, everything would be switched, meaning this is a small number, and I move the decimal to the left. Okay, and to the play pause it, I want you to try that one on your own. All right, ordering numbers in scientific notation. To order numbers in scientific notation, you must first make sure all the numbers are in scientific notation. You might be like, well, duh. And that is kind of a duh statement, but you'll see on the example here what can be a little tricky about that. Once in scientific notation, look at the exponent first. If the exponents are the same, the quote unquote tiebreaker is the A value. All right. So order these atomic particles from lightest to heaviest. So from least to greatest. Which of those particles is not given in scientific notation? Hopefully you see that it's the proton. What's wrong with it? Well, A is 16.749. That's bigger than 10. The decimal needs to be between the 1 and the 6. All right, so it needs to be over 1. It's a really bad arrow. It needs to be over 1, still a bad arrow, but you get the idea. Okay, now we haven't talked about this. It's sort of in scientific notation, but not quite. I need to move the decimal 1 more spot. Okay, this is what you should be thinking. Right here is important. Since I'm making the A value smaller, right? I'm changing it from 16.749 to, and I'm going to be changing it to 1.6749. That part's easy. It's how it affects the exponent, which is a little tricky. If I make the A value smaller by 1, which I did, I need to make the exponent larger by 1 to keep it balanced. So it was at -25. I need to make it larger by 1. Larger means add 1. So I'm going to add 1 to -25 and I get -24. Now all the numbers are written in scientific notation. Now I compare them and I see that -28 is the smallest, right? The more negative it is, the smaller it is. So the lightest one is the electron. No question about it. It's the smallest by mass. Okay, the electron is the smallest. Now I need to look at the other two. They both have an exponent of -24. They're tied, meaning I need to look at the A value. whichever A value is smaller is the next heaviest. Or whichever one's larger is the heaviest. That's another way of looking at it. So 1.67 so far they're tied. 1.672, 1.674. The neutron is lighter than the proton. The proton is the heaviest. Okay, now, if I hadn't changed this to scientific notation like that, most people would have neutron and proton switched because of what I said at the top. That's why it's important to get them in scientific notation first. Last part of this video is multiplying with scientific notation. This is the first case of this. We will have more cases coming up later lessons. All right, so multiply 12 times 9.1 times 10 to the negative 7th. A lot of people look at this and think distributive property. This is not a distributive property problem. Please keep that in mind. Okay, 9.1 times 10 to the negative 7th is just one number, and I'm multiplying that one number by 12. All right, so what I'm doing is I'm doing 12 times 9.1, and I'm just going to leave the times 10 to the negative 7th alone. So 12 times 9.1, grab a calculator, is 109.2 times 10 to the negative 7th. Now, that's not in scientific notation because 109.2 is bigger than 10. I need to move the decimal 2 spots. So it's going to be 1.092 times 10. Now I got to think about this. Did I make the A value bigger or smaller? Well, I made it smaller and I moved the decimal spot twice. So I made it smaller. I call it smaller by 2, which means I need to make the exponent larger by 2. So I have to add 2. Negative 7 plus 2 is negative 5. Okay. You can check that on your calculator. Do 9.1, or you could change 9.1 times 10 to the negative 7th into a very small number with like 0 point, and then it's 6 zeros and then 9.1, and then times that by 12. You should get that. Okay. Do one more example of this. All it is 0.5 times 1.2. That's 0.6 times 10 to the 8th. Nothing happens with that yet. Don't try to be fancy and do to multiply and change, because you see like this has to be changed before I can be done. Don't try and do it all in one step. Just multiply first and get 0.6. And now I'm going to move the decimal point 1 spot. Okay. I made A bigger this time, right? 0.6 to 6. I made A bigger. Making A bigger means I need to make the exponent smaller by 1. So I'm going to subtract 1. And there's my answer. Okay, that's it. We will go over this tomorrow in class a little bit more. Hopefully that helped. We'll see you tomorrow.